Section 8-2, Part 2. Here we have a graph of a line that has the point -1, -1. There's this point. And it has the point 2, 5. To the right 2, up 5. We see that a line has been drawn passing through these 2 points. Remember, rate of change is described as vertical change divided by horizontal change. So to go from this point to this point, what did we have to rise and what did we have to run? Well, I had to rise 1, 2, 3, 4, 5, 6. That's positive 6. I had to rise positive 6. That is my vertical change. That's where I get 6 in the numerator here. Then what did I have to run? I'm running to the right. That's positive 1, 2, 3. I had to run positive 3, which is your horizontal change. Rise is your vertical change. Run is your horizontal change. So I had to run horizontal change of 3. 6 divided by 3 gives you 2. Always reduce your fraction if you can. So the rate of change between -1, -1 and the point 2, 5 is 2. 2 is your slope. 2 is your rate of change. It says the rate of change of a linear function y equals to mx plus b is m. So m is your slope, m is your rate of change, and m is also the coefficient of x. See, I have y equals to 2x plus 1. Coefficient means the number in front of x. 2 is being multiplied times x. So anytime you have a number in front of x, that number's being multiplied times x, and that number is the coefficient of x. So if I ask you for the coefficient of a number, the coefficient of x, it would be the number in front of x. So 2 is your slope, 2 is your rate of change, and 2 is the coefficient of x. Next, we're going to be identifying equations of functions from graphs or tables. Identify the equation of each linear function shown from the choices given. Then state the rate of change of the function. So first, we're going to take this graph and we're going to determine which one of these equations represents this graph, okay? So let's look at this graph. The first thing that I'm going to do from this graph is determine points. I see here this graph passes through this point and this point. Well, each little marking, let's determine what each marking represents. I have 0, a marking, and 1. What's halfway in between 1? Take 1 and divide it by 2. Wouldn't that be a half? Okay, so that's a half. 1, this would be 1 1/2, which another way to write 1 1/2, let's practice that. Another way to write 1 1/2. This is a mixed number. Change it to an improper fraction. You say 2 times 1 is 2, plus 1 gives you 3 halves. So another way to write 1 1/2 would be 3 halves, okay? Then 2, then 2 1/2. What's another way to write 2 1/2? Improper. Multiply. What's 2 times 2? 4, plus 1 would be 5 halves. So 2 1/2 is the same thing as 5 halves, and then you would have 3, okay? So the name of this point would be 1, 2, it would be 0, 3. The name of this point is 0, 3. The name of this point, remember this is a half, okay, and this is 1. So the name of this point is 1, 0, okay? So I have 2 points, 0, 3, and 1, 0. So what we want to look for is, of these 4 equations, which one of these have these points, okay? So let's try the first one. Y equals to 3x plus 3. If I was to use a table I'm going to pick 0, 1 for sure, because these are the same points I found here that's on my graph. If I plug in 0, I have 3 times 0 plus 3. 3 times 0, 0 plus 3 gives you 3. That's the same point that was on the original one. All right, let's plug in 1. Y equals to 3 times 1 plus 3. Well, what is 3 times 1? 3. What's 3 plus 3? 6. So you see, both of these points are not identical to these. These are the line, the given line. These are points on the given line. So we're trying to find the equation that has the same points. I could also find another point on the given line. There's another point on the given line. It would be a half up 3 halves. So I could use a half, comma, 3 halves. That's another point on the given line. A half, 3 halves. That's this point. 1 half, 3 halves. So I know it's not this one. I know this is not the equation. But this one. Now, honestly, I knew this was not my answer because I have a positive slope. This line has a negative slope. So let's try this equation and find some ordered pairs. Y equals to negative 3x plus 3. Let's find some ordered pairs for this one. Let's pick 0, 1. All right? If I plug in 0 here, that is negative 3 times 0 plus 3. Well, what is negative 3 times 0? 0. What's 0 plus 3? 3. That matches the original one. All right, let's plug in 1. What's negative 3 times 1 plus 3? Well, negative 3 times 1 is negative 3. What's negative 3 plus 3? Don't I get 0? So do both of these match the points from the line given? Yes. Therefore, this line goes with this equation. This is the equation of this line. The y-intercept was positive 3. You had a slope, rise negative 3, run 1. Rise negative 3, run 1. Okay? So this is the equation for this line. Next, let's determine which one of these 4 equations matches this table. Okay? So I'm going to recopy that table. I have the table. Negative 2, negative 2/3, 0, 0, and positive 2, positive 2/3. Okay? So I'm trying to pick which one of these equations is the equation that represents these table of values. Okay? Now, looking at our graph here, we know this one passed through the origin. So I know it's not this one, okay? This one passes through the origin. This one does not pass through the origin. So I know it's not this one, okay? It does not contain the point 0, 0. So I know it's not this one. All right, so it's either y equals to 3x plus 3, or y equals to 1/3 x, or y equals to 3x. All right? So my question is, which one of these equations goes with this table? All right? So let's just start finding some points. I'm going to find some points on this one equation. I'm going to find some points on this one, and I'm going to find some points on this one. So I'm going to use my table on each one. Now, all of these points here must appear on one of these 3 in order for me to determine which equation goes with my table of values. All right, so let's plug in negative 2, 0, and 2. Being these are the points that I have been given, I'm going to pick those numbers and plug them in one at a time into my given equations. So plugging in negative 2, y equals to 3 times negative 2 plus 3. So what is 3 times negative 2? That's negative 6. What's negative 6 plus 3? That gives me negative 3. Is this point 1 in my table? No, negative 2 goes with negative 2/3. So I know right now it's not, this equation does not match this table. All right, let's see if it's this one. Let's plug in 2. N for x. Y equals 2, 1/3 times negative 2. Well, negative 2 is over 1. To multiply fractions, multiply straight across. 1 times negative 2 would be negative 2. 3 times 1 would be 3. So yes, it does match. This point matches. But we must check them all in order to know if it's the correct equation. All right, plugging in 0 into this equation, 1/3 times 0, I get 0. Does that match the original chart? Yes, 0, 0, okay. And next, let's do plugging in 2. I have 1/3 times 2. Well, 1/3 times 2, 2's over 1. If you multiply straight across, 1 times 2 is 2, 3 times 1 is 3. So I get 2/3. So do all three of these points pair up? Negative 2, negative 2/3, 0, 0, 2, positive 2/3. Yes. So this is the equation that matches this table of values. No need to even try this one. Now, I could have graphed these and determined that this was the equation, but what they wanted me to do was take the table of values and see which one of these three equations had the same table of values as the original one.